Hey everyone, welcome back to Scalar. So in this particular video, we are going to talk about RAG components and implementation. But before we get started, don't forget to subscribe to our channel so you don't miss the rest of the Agentic AI series. And if you are serious about building your career in AI, then do check out Scalar's Advanced AI and Machine Learning program, co-certified by IIT Roorkee CEC. It's designed to help you master the skill needed for the real-world AI role. The link is in the description box. Also, tell us in the comment what other AI topics you would like us to cover. So let's get started.
So we have already talked about the entire RAG framework. I'll just quickly draw it. So let's say this is my PDF file. And what we need is we need some kind of system which can fetch this PDF file from my local drive or from let's say anywhere in my system to my application, to my Python code, to my entire system or application. And that is where we need these document loaders. Document loaders. So once they load it in a document data object, which is basically the data object of Langchain library. After this, we have also talked about the chunking process. So as we know that we cannot provide the entire document to our LLM. The problem is that the context window is limited. Also, your LLM might give you a wrong answer because you have provided with a vast text to read from. So that is going to be a problem. So here, the process of chunking will basically divide or break this entire document into smaller chunks, and we have already talked about how this process works. But in order to facilitate this process, I would need some text splitters. And once we are done with this, now we need to convert these chunks, which is nothing but the group of text, into a vector. Now we have already talked about this particular process, so I will not go into the depth of why this is required. But when I say that I want to convert this chunk, which is nothing but the collection of text, into the vector, which is known as the embedding vector, the objective is that I want to summarize or I want to represent the semantic meaning of this chunk or the text which is available in this chunk into a vector. And the reason we are doing this is to facilitate the process of similarity search, to facilitate the process of retrieval, to facilitate the process of even recommendation. So all these process can be facilitated when you have converted, when you have represented this chunk, which is a group of text, into representative number, which are known as embedding vectors. And it is not simply mapping. I'm not mapping a word with a number. I am trying to use a neural network which is going to perform some kind of mathematical operation to convert this textual information into a vector representation, keeping in mind that the semantic meaning is also captured in very good detail. So I have converted each of this chunk into the embedding vector. Now, in order to make sure that we are able to reuse these vectors for a variety of operations, let's say you want to use these vectors for similarity search or maybe for recommendation system or maybe for your RAG system, I need some place where I can preserve them. So in order to preserve these vectors, we cannot preserve them in simple flat file system. We cannot preserve them in our RAM. We cannot preserve them in our regular database also. We need a specialized database. And that is where this vector database comes into picture. So this is your Vector DB, also known as vector store. Though there is a very minute difference between a vector store and a vector database, but as of now, let's assume this is a vector database. So vector database is very similar to your database concept that you would have learnt about. The only difference is that these vector database are fine tuned and they were created to make sure that NLP engineers are able to preserve the vectors, the embedding vectors into some database. Now, these database holds your vector in two formats. One is the vector, which is basically a numerical representation of the entire text. Plus, it also preserves the metadata of that particular vector. So let's say if this chunk has some metadata, your vector database will not only just preserve the vector associated or representing that particular chunk, but also will preserve the metadata. So this is what gets inside your vector database. Now, there are multiple things which comes with this vector database. So first of all, why we need this vector database? We need this vector database so that we are able to reuse these vectors which we have generated. I hope you remember that in the first or the second video, I've told you that you do not need to worry about how this chunk will be converted into the embedding vector. Here we can use the embedding models. Embedding models. And I think we have used the OpenAI embedding model. Now, since we are using OpenAI embedding model and OpenAI will charge you for it, right? Though the charge is very nominal and it is not going to be very much high. But since you are paying for this service, which is converting a chunk into a vector, you need to make sure that you do it minimum number of time. And hence, the very first requirement is that once you do this process, once you convert this chunk into a vector, you are also able to preserve it somewhere so that you can reuse it multiple times, so that you do not have to keep on reusing this embedding model again and again to regenerate the vector representing your chunk. So this is requirement number one. I want to reuse. And hence I need the vector database. Now, the next reason why we need this vector database is for our RAG application and similarity search. So, for example, now if a user sends me a query with some question, let's say, what's his age? Now I have written a very open-ended question. And if you provide this question to your LLM will not be able to answer it because LLM does not have the context. I might need to change this question because this question would also be not, or maybe yes, this will be fine. So let's use this question itself. So let's say this is the query, and if you provide this query directly to your LLM will not be able to answer this question because LLM does not have the context. Now, let's say this document which you have loaded was of Mr. Narendra Modi. So let's say this document is basically the Wikipedia page entirely covering every detail of Mr. Narendra Modi. We loaded this document into our document data object. Now we chunked it, we splitted that document into various chunks, and finally we converted each of this chunk into a embedding vector. Finally, we preserved this embedding vector into a vector database. Now what the similarity search will do is, if I use this query and provide this query to my vector database comes with a functionality that it can help you with the searching operation also. So vector database is not just limited to preserving your vectors corresponding to the chunks. Vector database comes with one more functionality. Vector database can also let you do the similarity search, and this similarity search is based on what is known as cosine similarity. You can change the similarity search mechanism also as per your choice and as per the metric you want to use. But if you provide a query to this vector database has inbuilt functionality to search search for this particular query, what is the nearest chunk or what is the nearest vector that is matching this particular question. So internally what it will do, it will basically take this question, will convert this into a vector, and will perform the similarity search. So this is going to happen internally, and vector database comes with this kind of power that it can do this operation also. So first reason why I need vector database is to enhance reusability. Second is vector database can also provide you with the flexibility to search. Vector database also comes with something which is known as indexing. Now, those of you who are familiar with the concept of database, they might be aware about this concept, which is indexing. Now, what is indexing? Indexing is a way to organize your records in the table so that the process of searching becomes fast and become optimized. Now, if you have a database, and I'm talking about the regular database, let's talk about the RDBMS database. In RDBMS database, we generate primary key, and primary key automatically gets indexed. So the type of indexing which primary key follows is known as clustered indexing. Those of you who are not aware about this concept, please don't worry about it, just ignore it. But those of you who are aware about this concept, I hope you are able to relate to it. So vector database also comes with a kind of indexing mechanism, and there are multiple indexing mechanisms which are available in the vector database. Now, why we need indexing? We need indexing because I want to make sure that I am able to search for the relevant document or the relevant chunk as soon as possible. I am able to optimize, I am able to fast track the process of searching. So if you want to search fast, you need to make sure that the searching process is somewhat optimized, is somewhat logical, it's somewhat controlled. And that is where the concept of indexing plays a very important role. So in vector database, the concept of indexing is inbuilt. You can choose what kind of indexing you want to apply. There is one very simple indexing which is known as, I think, inverted file index. Now this indexing works on the concept of clustering. So what it do, so let's say your database has, let's say your database, let me just change the color. So let's say your database has around 1 million vectors. Now 1 million vector is a huge number, right? And when you give a query to this vector database to search, what it will do, the brute force approach is it will go to each and every 1 million vector and perform the similarity match. So it is basically finding out the angle between the chunk, which is one vector, and your query. And it will do it for all the 1 million records. And that is going to be very, very, very slow. So we need some kind of mechanism to fast track this. So if your vector database has 1 million vectors, what this particular inverted file index technique will do, it will perform a k-mean clustering. Now, those of you who are not aware about what is k-mean clustering, it is basically a is unsupervised machine learning technique of putting the similar uh, records or similar item together. So what we are essentially going to do using k-mean clustering on top of these 1 million vectors is I will just group those vectors which are similar to each other in one group. So let's say this is G1. So this G1 comes with all those vectors which are similar to each other. Let's say this is G2 and let's say this is G3. So let's say we have created three groups such that each group has some vectors in it. Now each of this group will have a centroid. A centroid is basically the average of all the vectors in that particular group. So when you take the average of all the vectors in a particular group, you get a centroid average value. Now, when you provide your question to your vector database, the vector database will convert your question into a vector and then will match your vector with this centroid C1, this centroid C2, and this centroid C3. Once the match is done, you would be able to understand that your question is similar to which of the group. Once you have identified the group, so let's say we have identified the group as G3, then what we'll do, then we will go into the brute force approach of matching each vector in this group with your query vector. And this is a faster way of getting your task done, getting your search done, instead of going through each and every vector in your vector database. So this technique is known as inverted file indexing technique. But like this, we have multiple indexing techniques available in the vector database. So this is another advantage of using vector database. Now the final advantage is you get the CRUD operation or CRUD functionalities also. Again, this is something which is very similar to what we have in RDBMS. You can create, you can retrieve, you can basically update, you can delete also. So all these operations are available in your vector database also. Now in Langchain, so Langchain provides vector database as a component, and since it is a component by Langchain, it is also a runnable. So in Langchain, we have multiple vector database which are available to us. So one of the database which is available to us is FAISS. This is basically the vector database from Facebook. So this is known as Facebook AI similarity search. Second one is Chroma. Another one is Pinecone. Another one is WaveNet, Waviate, and Quadrant. So all these databases or all these vector database comes with some positives, some negatives. But as of now, since we are trying to learn, we will be looking at the usage of FAISS and ChromaDB. Or both of them are very simple to use. There is nothing difficult in understanding and using these database. If you have understood the core concept of what exactly is vector database and why we need it. Now with this, with we understanding this, let's now jump into the code and let's code them. So let me reconnect this. So this is a code that I have written. Basically, we will be reusing this code again and again. So I have pre-written this, updated my environment variable with all the API keys, and then finally we have all the necessary package. Since I'm going to use Gemini model, so I have Google Langchain, Google Gen AI. I have instantiated my, I think I need to yeah, I think I need to do it again because my runtime has been updated. So let me just quickly set up my system, rename this to .env. Then I will be able to run this, and this. So let it run. Meanwhile, what I'll do is I'll first of all create a embedding model for uh, Google Generative AI. So basically, if you want to preserve your vector into a vector database, you need to first of all convert your text or a chunk into embedding. And for that, you need some kind of embedding model. You can use OpenAI embedding, but for this particular demonstration, I'll be using Langchain underscore Google underscore Gen AI. dot import Google generative AI embedding, and we can initialize the embedding with Google generative AI embedding. And here I'm going to use a model which is your model slash text hyphen embedding, and this is 004. um, let's run it. So this is also done. We have the embedding model created. Now let's initialize the ChromaDB. So ChromaDB is now available. So previously it was available in Langchain community.vector store, but now Langchain has created a separate library for it. So ChromaDB is available in Langchain underscore Chroma. So pip install quickly. So I will first of all install the ChromaDB Langchain underscore community. Finally, Langchain underscore Chroma. I need these three things. And let's get from Langchain underscore Chroma. I will import Chroma. Okay, there is a problem. Okay, there is a problem over here. Okay, so we are done with this. Let me delete this. This does not look good. Clear output. Yeah. Now, what we will do is we will first get a PDF loaded. So let me load the PDF over here, which I have created. Yeah, over here, cities PDF. We will get the PDF loaded. Let's copy this path and let's get the py PDF. So from langchain.document loader. Before that, I need py PDF. So pip install -q py PDF, and then from Langchain underscore community dot document loader py PDF. This is the link, and let's load. So doc is equal to loader dot load. So we have the documents created, and as you know that uh, this loader will create as many number of document objects as number of pages you have in this PDF file. So right now I have 5 pages. I can quickly show you this also. So this is the file. We have 5 pages where each page talks about a specific country. Sorry, I'm really sorry. A specific city of India. So we have Kolkata, Jaipur, Bangalore, Delhi, and Mumbai. So this is the file we have, and here you can see we have 5 documents. So if I quickly check the length of this, the length of doc, I should be able to see why there is 1 second. Yeah, so here you can see we have 5. Okay, now let's create a vector store object chroma. This takes your number one is embedding function. Embedding function is basically the embedding model that will convert your document into embeddings. So since I'm going to use this embedding model em, which we have generated over here, so I will simply write em over here, comma. Then it wants you to define the directory. Directory is basically the location where it will physically preserve your database. So basically in this folder, it will generate this folder named ChromaDB where it will preserve my vector embeddings. So that is what this persist. persist directory basically mean? Finally, there is one more parameter known as connection name. Now, what is collection name? Collection name is similar to what we have a database in RDBMS. So in RDBMS, let me just open TL draw. So in RDBMS, I hope you remember that within a server, we have multiple databases, and within databases, we have multiple tables. And within a table, you will find out multiple records and the columns or the fields, right? Similarly, in your Chroma database, you have multiple collections. Within a collection, you will have multiple vectors. And within a vector, you will have two things. One is your vector, which is the numerical representation of your chunk. Other one is your metadata. So this is how the structure will look like. Very similar to RDBMS, the only difference is here we have the Chroma database. So Chroma provides you with this flexibility to also design a folder. Now this collection is like a folder within your database where you can preserve your vectors with the metadata. So this is what over here we are doing. So once this is done, let's run it. We have created our vector store object, and now we will add the document into it. So vs dot add underscore documents. Now you can add text also, you can add image also, you can add document also. Here if you can see, we have add document, image and text. Now since this doc is a document object which has multiple documents, I will be using add documents. But if you want to add a text also, you can use add underscore text, and you can add an image also. So let me add this. 1 second. Embedding content message status not found. Okay, what might be a issue? I think it is related to embedding models. Okay. Vector store is this, and now it should work. Yeah, so this is done now. So what you get in the output is basically the ID. Now this is not a vector, it is just the ID. This ID is corresponding to your uh, document number 1, document number 2, document number 3, and so on. So if I just check VS now, you will see that VS is a vector store object, and if you say vs.get, you will see everything. Now you can see that first of all you have all the IDs, comma, you have embeddings is equal to none, then you have document, document, and finally you have the metadata and basically everything which is available over here. So this is what your vector store is doing. Now vector store provides you with the similarity search also, and you want to do it, you just say vs dot similarity search, similarity search by image, similarity search by vector, similarity search by, so you can see we have multiple methods available. I will use similarity search, and you will put your query over here. So query is equal to which city has multiple forts, and I want to get two relevant documents. So here you can see that first city that I'm getting is the national capital Delhi, and other one is the Jaipur. The reason I'm getting Delhi and Jaipur is because in Delhi I might be having the keyword Red Fort, if I remember. Yes, over here Red Fort, and here also I will have some fort, yeah, Amber Fort. right? So the reason this the we are getting these two results is because of the keyword fort. You can also use keyword vector search using score also. So similarity search with score. The only difference is you will get a score also now, and score is basically the cosine similarity. So lower the score, better the similarity. So here the score is 80, here the score is 84. So this is the lower score, so this is the closest match, and this is a near close match. So this is what you get when you use a similarity search with a score. With this, you can also update, you can also delete also. So if I just simply say vs dot update update document, and here you need to provide the document ID. As of now, I'm just leaving it blank just to show you the code. And then you mention the document, and here you mention the updated document. So for example, if you want to update a specific document, after adding it, you have to get this ID, and that is what you place over here, and then the new document over here, and this will update your document in the vector store. Similarly, if you want to delete some document or vector, just say vs.delete, and this will also take your list of IDs. So in the list of IDs, you add all the IDs that you want to delete, and you will be able to delete it. So CRUD operations are available, similarity search is available. You are able to convert your entire document, which we have loaded from the PDF, into the embeddings, which are getting preserved in your vector database. And this is your vector database. You can use FAISS also in a similar way. The advantage is that the process is exactly the same. You create the vector store object, and then you just do the same thing. All the methods are exactly the same, nothing different. So that is a kind of flexibility and advantage you get working with Langchain. But I will show you the usage of FAISS also when we will talk about retrievers, which we are going to do now. So let's start talking about what are the retrievers. Now let's talk about what are the retrievers. So as I told you that the reason I need retrievers is to facilitate the process of uh, getting relevant documents. So basically, you must be thinking that if we talk about the vector database, using vector database, we can perform the operation of similarity search. And we have seen in the code also that vector database which we used was the Chroma database. Chroma database provides you with the method which is vs dot similarity search, and similarity search with a score. If these methods are available, then why we need another component which is retriever? The number one reason is retriever is a runnable, which basically mean you can plug in the retriever in your chain so that you are able to perform complicated tasks and create applications around the retrieval process also. So this is advantage number one, that you can create chains because it is a runnable. When it is a runnable, that means it provides you with the method invoke. So you do not have to use the method which is dot similarity search or dot similarity search with the score. You can use the method which is invoke so that it can become the part of the chain, and you are able to execute the chain in one shot. Second advantage is retrieval also comes with these strategies. So using this particular similarity search which is provided by the vector database, you don't get the flexibility to decide what kind of searching methodology or what kind of retrieval strategy you want to use while doing this task. So retrieval or retrievers in Langchain also comes with these strategies. So there are multiple strategies. One very popular strategy, which I have written in my document also, is maximal margin relevance. relevance. And one more strategy which is we will talk about is your multi-query retriever. Let me first of all explain what is a plain or vanilla retriever, and then what is maximum margin, and then what is multi-query, and then finally we jump into the code part. Again, writing a code will take fraction of our discussion. Understanding is very important because this is a very important interview question. Why one should use maximal margin, which is also known as MMR and MQR. So why one should use MMR and why one should use MQR. Let's first of all understand the vanilla version of retrieval. So what is the main goal of retrieval? The main goal of retrieval is that if a user sends a query, the retriever, so this is my retriever, the retriever will take that query, will convert it into the vector. I'll write V, and then retrieval will have a broader scope. So let me not limit it like this. Let me write the entire process and then I will bound it. So query will be taken by the retriever. It will convert that query into embedding vector. Will take this embedding vector into your vector store, will perform the similarity search, and will return you the K documents. So if you now want to just create a bounding box, then this is what your retriever will look like. Oh, my bad. Up to this. So this is what your retriever is looking like. So retriever takes the query from the user, will convert that query into the embedding vector using the same embedding model which your vector store has used. Then we'll take that embedding vector into the vector store, perform the similarity search, and then we'll return you the K document, where K represents the number of similar documents to your query. And K is a hyperparameter you can define. So this is your retriever. And this is your vanilla retriever. As I have told you previously also, the reason I need a retriever is because this is a runnable and I can make this component the part of my chain. I can execute this using the method which is invoke. This is very important. Now, one thing which is very important right now is that though I can do this using the vector store method, which is similarity search and similarity search by with score, we can use the techniques over here. So retriever also provides you the flexibility to define the technique of retrieval, which is you can define you want to use MMU or M MMR and MQR, MMR and MQR. So which technique you want to use, plus you can define the value of K. So this is what the hyperparameter which you get if you use retriever component in Langchain. Now this was your vanilla retriever. Vanilla means simple, straightforward, nothing complicated. But why we need MMR as a strategy? Why we need MQR as a strategy? So let's understand the vanilla version as of now. So what happens is, let's say if this is your query, Python programming, if this is your query, then what you get in the output, if you are a value of K is 5, this is what you get. Python is a high level programming language created by this person. Second is Python is a programming language known as simple. Then third one, Python is a popular programming language. Then fourth one, sorry, Python programming language has extensive. Python language is widely used. Now, as of now, you will agree with me that this is good. Like When your query is Python programming, your retrieval has returned you 5 documents which are very close to your query. And that is what the objective of a retrieval is. That retriever will try to find out the closest match. So it will return you the top k closest document, right? But there is a big problem over here. If you closely observe, all these documents are basically talking about the same thing, and there is no such diversity in these documents. So the major problem is this result lack diversity of the document. So when I say document diversity, I basically mean I need a document which is similar to my search query. I need a document which is talking about Python programming, but I need that document which is little different from my already selected document. So now there are two objectives. Number one objective is I need a document similar to the search query. Second objective is I need that document which is different from other selected documents in my result. So basically, this is what your MMR tries to fulfill. It tries to bring in diversity in the selected documents or the matched document. It tries to make sure that it is, number one, able to pull out all those documents from the vector store that is matching with your search query. Plus, it will also try to make sure that all those documents which it has pulled out are different from each other, so that when you combine this and provide it to your LLM, the LLM is able to get a diversified context to create a better result. And that is what your MMR is trying to do. I have created one more example over here if you read it. So let's say if my search query is Italian restaurant in New York. Now, the standard retrieval process will return you this, that Mario Pizza and this pizza house, this one, this one, this one. So you can see the problem is you got 5 pizza places, no variety. But this is your MMR result. You got this, then, so this is high relevance, relevant plus different cuisine style, relevant plus different atmosphere, relevant plus different experience, relevant plus different ambience. So you get diversified Italian restaurant, pizza, seafood, fusion, home style, outdoor dining. So this is what the advantage is. This is what you will get when you use the vanilla retrieval process. This is what you get when you use MMR. MMR is trying to do only one thing, no, exactly two things. Number one, when it is trying to fetch, it is trying to fetch the closest match, plus it is trying to enable the diversity in the selection. That is what MMR is solving. Second was MQR, and MQR stands for multi-query retrieval. Now, what is multi-query? The problem is that whenever a user sends a query, the query can be very vague. So let's say if I say query is suggest 5 places to dine, or maybe let me just pick a question which is little more ambiguous. I want to get fit. Now, when a user is sending a query, when a retrieval takes this query, the problem is that this query is a vague query. And when a vague query is sent to the embedding or vector store, it is highly possible that the results which are fetched out or the documents which are fetched out are also wrong. So the multi-query retrieval is a process where it uses a LLM as a helper LLM to generate multiple queries associated with this query. So what will happen first is this query will first go to one LLM, where this LLM will generate multiple queries. Let's say it has generated 4 queries. One is I am looking to get fit, get fit and healthy. Similarly, let's say next one is suggest ways to get fit and healthy. So like this, it will generate 4 different queries. Now each one of this query will go to a particular retrieval R, 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 R. Each one of them will perform the retrieval process using the process of MMR. So it will return me, let's say, top 5 document. It will return me top 5 document. It will return me top 5 document. It will return me top 5 document. And out of those top 5, which we have searched using the process of MMR, now finally the top 5 will be picked based on the similarity score. So this is a process which MQR is following, which is multi-query retrieval, where the objective is to generate multiple queries so that the ambiguity related to the query of the user can be reduced by generating multiple queries, and then we follow the simple process of MMR. This is what your retrieval component is of Langchain. Now, once you have understood the theoretical concept, let's quickly jump and code this out. Okay, so now what we are doing to, once we have created our vector store, so this is my vector store, which has 5 documents as of now. Using the vector store, I can create a retrieval or retriever. So vs dot as underscore retriever, and this takes a parameter which is search underscore keywords kw and k is equal to 2. I will preserve this in a variable ret, and this is my retriever which is ready. So now this is a runnable. Using the vector store itself, I have created a retriever which is going to return me top 2 documents if I invoke this. So if I just say ret.invoke, and since it is a runnable now, I can just simply invoke with my question, which city has multiple forts. You will get 2 documents in a list. You can see document number 1, document number 2. Document 1 is Delhi, document 2 is Jaipur. So this is the simplest way of converting your uh, vector store as a retrieval. Now let's implement MMR, which is maximum margin relevance. But before that, I want to change the vector store now. Let me also show you the process of FAISS. So FAISS, FAISS. So for FAISS, I need to first of all install this additional library, which is FAISS CPU. If you are working with GPU, you can use FAISS GPU also. But as of now, we have a very nominal task of, we are not doing any heavy loading. So FAISS CPU will work and will be sufficient for our process. The loading process is very similar to what we have done. So from Langchain dot underscore community dot vector store, I want to import FAISS, and we will create a vector store. So vs is equal to FAISS dot from document. So basically I am preserving these documents. So from documents and documents and the embedding model. Now this is my vector store which has 5 documents, and if I just say vs.get, oh, अच्छा FAISS में we don't have a get, FAISS में we don't have a get, then FAISS में what we have, FAISS में we don't have a get, then what we have, we have get by IDs, and we have doc store, embedding function, distance strategy, embeddings. So these are the embeddings. This is the embedding model. Okay. So get IDs I think will work. Get by IDs. Okay, this is a function maybe. I am missing out on something. Let me just check it again. Get my ID index to doc store. Okay, let me pause the video and just search it. Okay, so I was able to search for it. I was able to come up with the answer. The answer is basically ChromaDB is an external, basically a altogether library. So we have get, we don't have a get over here, but we can convert this into a retrieval. So let's convert this into a retriever first of all. vs dot as underscore a retriever. Again, the same thing. Search keyword is, I don't want this as of now. Search keyword is 2. Now here itself, I will add one more uh, parameter, which is search underscore type is equal to mmr. Now in this dictionary, I will add one more parameter, which is lambda 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 underscore mult is 0.5. Now I'll tell you what this is, but let me just run it first. So we are done with this. Let me preserve this in a variable ret retriever, and now I can say ret dot invoke where is red fort. So you will get two relevant document. One is again Delhi, another one should be Jaipur. Yeah. Okay. Now let's understand this. So first of all, the difference between this retriever and this retriever is that this particular FAISS retriever has been created with the strategy of MMR, which we have talked about. Second thing is the lambda parameter. Now, what is lambda? Lambda controls the amount of diversity you want to add. So when your lambda is 0, now this talks about the scenario where the diversity is very high. So diversity is very high, which basically mean it will try to find out those documents which are very different from each other. So in this case, you might end up getting very different documents. And in the scope of finding out different document, your retrieval might be wrong also. So this is not a good value of lambda you should go with. Lambda as 1 is a vanilla retrieval. So this is vanilla retriever, which basically means no diversity. So you have to somewhere land in the middle where we choose zero point 0.5, but this is a hyperparameter. You can uh, play with it. So this is a balanced approach. So that is the reason I have used zero point 0.5. So I hope you are clear with this also. Now let's talk about how we can implement the MQR strategy, which is multi-query retrieval. So for multi-query, I need to get the multi-query from Langchain Classic. So I'll install it. I think I have already installed it. So from Langchain underscore classic dot retrievers dot multi-query import multi-query retrievers. Now, multi-query retrievers will first of all, so it takes two things. Multi-query retriever dot from LLM. It takes your retriever. My retriever is, so let me just copy this. I want to just enable the same retriever, but the next thing that it takes is the LLM, which is my this model, the Gemini model, which I have instantiated over here. Okay. So this is the two inputs that you need to give. This LLM will generate multiple queries against my user query, and then the regular retrieval will play the role. Now let me use this multi dot invoke. Where is red fort? Again, the result will be very similar. You will get top two results, but now you can see it is taking time. The reason it is taking time is because it will first go to my LLM, will generate multiple queries, and then the first one is Delhi, the second one is Jaipur, but the answer is same. But I hope you are able to understand the importance of MQR. MMR, MQR are two very important interview questions. So I hope you guys are clear with this particular topic. So with this particular topic, we have finally completed the conceptual understanding about the RAG components, all the components that I need to build the RAG system. Now the next video is going to be something which we are going to develop the notebook LM for us. So let's meet in the next video. Till then, I really want all of you to please put your comment down, and please help us with your feedback so that we can understand if we are able to provide the type of content which we are working on right now. And if you guys are feeling excited, if you're feeling amazing after completing each video, please show your love, please show your support to us by putting your comments, by liking this video, by sharing this video with your friends who are also looking to upskill in the generative AI field. I will see you in the next video. Till then, take care and keep learning.